So moving on with trig, we are going to look a little bit further into our graphs of sine and cosine and see how we can transform them, what the values mean, and go from there, start to graph them by hand. So our basic sine and cosine graphs we could see on this page. The first one being our sine curve, noticing the difference from cosine, sine starting at 0, where cosine actually starts graphing on the y-axis at 1. However, they all have a range in between +1 and -1. I can see that for both sine and cosine, and they look pretty similar. So we're going to keep that in mind. So with some of our transformations, we can take a look at the graph and maybe I can shift one to make the other. And because I can do something like that, each of these graphs are called a sinusoid. Any transformation of a sine function, maybe a graph of such function, is considered a sinusoid. So in general, we can write a sinusoid's function. It's going to be a sine, parentheses, b, x minus c plus d. And a, b, c, and d, they're all constants. A nor b is going to be 0. If it was, we would lose our entire function. Okay, parts of this function that we need to be aware of. So special vocab. Anytime we're doing a horizontal stretch or shrink, it's going to affect the period of the graph and the frequency. Any vertical stretches and shrinks will affect the amplitude. And horizontal translations are going to bring about what's called phase shifts. So slight different vocab when we get to trig when we are comparing it to transformations. Okay, so the amplitude of the sinusoid is going to be our absolute value of a, so the number in front of the sine, which hopefully that makes sense because back here we were saying it was the vertical stretches that would affect the amplitude. That value of a being the number in front of our function, we typically say would be the vertical stretch or shrink. So our amplitude is going to be that a value, absolute value of a value. Same thing if it was a cosine graph. And graphically speaking, the amplitude is going to be half the height of the wave. So if we were to take a look and find the amplitude of each of these functions, and then think about it in terms of transformation. So this first one, again, I'm looking for that a value. I can see the amplitude of this function is going to equal 2. Now, as far as transformations go, we would say that is a vertical stretch by 2. Okay. Look at number 2. Even though it's a -4, remember we want just the positive value. We're trying to see the height. Height's always measured with positive numbers here. So we're going to say the amplitude is 4 because it's the absolute value of a. And if we were to look as far as transformations, we could have 2 things happening now. So we're going to have a vertical stretch by 4, and that negative is a reflection because I'm negating the entire function. I can say it's a reflection over the x-axis. Okay, another property that we get with trig functions is what's called the period. The period of the graph is going to be calculated by doing 2 pi divided by the absolute value of b. B going to be the number in front of that x. And the same thing would happen if it was cosine, same location, same formula. Graphically, the period is the length of one full cycle of a wave. Okay, so if we were to look at this numerically, thinking 2 pi over the absolute value of b, b being the number in front of the x variable, I'm going to take a look at cosine, and I see it has a -7. So I want to think again, absolute value of that number. So 2 pi divided by the absolute value of -7. That means I'm going to have a period of 2 pi over 7. Now, that number with the x, now that's going to give us a horizontal transformation. And our horizontal transformations, we always said, were kind of backwards from what we expected them to be. So we can say it's a horizontal shrink by 1/7. And now the negative, since I'm negating the x, that's a reflection over the y-axis. Okay, for number 4, again, I'm looking at that b value, the absolute value of b, so I can say the period is going to be 2 pi divided by 2, which if I reduce it, the period is pi. Transformations, that would tell me, just focusing in on that 2, it's a horizontal, think backwards, shrink by 1/2. And the 3 in front would tell us it's a vertical stretch. Vertical is typical by 3. Okay, also telling us that's the amplitude. Amplitude's 3. Okay, and then the last characteristic that we get for our graph is the frequency. So the frequency, easiest way to remember it, it's the reciprocal of the period. So if you can find the period, you can find the frequency, just flip it upside down. Okay. Graphically speaking, the frequency is the number of complete cycles the wave completes in 1 unit interval. Okay, so we're going to find the frequency of this function, and we're going to interpret it, and then we're going to try and graph 2 functions, or 2 periods of this. So the frequency of this graph, well, if I'm thinking the period, so I remember the period of the graph is 2 pi over the b value. And our b value in this case is 2/3. So I have to go back and think, what do I do with fractions? Think copy, change, flip. So copy, change to multiply, flip your second fraction. Okay, tops with tops, bottoms with bottoms. So that's going to give me 6 pi over 2, and when I reduce it, that's going to give me 3 pi. Now keep in mind what we just found. You found the period. So if we want the frequency, it's the reciprocal of that. So that's 3 pi over 1. The reciprocal would be 1/3 pi. So if I were to interpret this meaning here, this would tell me I would get 1 full cycle in a value of 3 pi. Which that should make sense, because if the period is 3 pi, and again that's telling us 1 full cycle, that should kind of help make that connection between period and frequency. Okay. If we're going to sketch this by hand, then the next thing that we probably also need to know is the amplitude. And the amplitude of our function is that a value. The a value of this graph is 4. So again, that's going to tell us the height. Okay, so if we try and put this all together, I like to graph the positive side. You could graph part positive, part negative. It's up to you, as long as we get 2 full periods. So I like to start by marking my 1 full period, which is 3 pi. So if I need 2 full periods, that means I need 2 3 pi's, or a total of 6 pi. Every curve that we get, I can split it up into quarters. So first I think, let's start with 3 pi and take half of 3 pi. So that's 3 pi over 2. Now if I take half of a half, that's going to get me my quarter. So that's going to leave me with 3 pi over 4. And now I can mark out all of my quarters if I think count by 3 pi's over 4. So 3 pi over 4, 6 pi over 4, that reduces down. So through 6 pi over 4 and another 3 pi over 4 would get me 9 pi over 4. Add on another 3 pi over 4, so 9 pi and 3 pi, that gets me 12 pi over 4, that reduces down to 3 pi. Add on another 3 pi over 4, now we're up to 15 pi over 4. Add on another 3 pi over 4, so that's going to bring us to 18 pi over 4, or reduce it, 9 pi over 2. So we're at 18 pi over 4 plus another 3 pi over 4, that's going to give me 21 pi over 4. And if I do that one more time, that's going to bring us up to 24 pi over 4, which reduces to 6 pi. Okay, so you have your x-axis all graphed out. I know that was a lot and not the easiest one. We'll do more in class, so don't worry. Amplitude is 4, so I know my tallest and shortest point is going to be +4 and -4. And then the last thing I want to think about is sine. So it's a sine graph. I know sine starts at 0, and the first motion is going to be an up motion. comes back down to the x-axis, keeps going down, comes back up. So I can see this is one full sine curve, and our frequency set, I should be able to see one full sine curve and a value of 3 pi. And there it is. So if I go again, I know it's going to go up, come back down, go below the axis, back to the axis. So we wanted to see 2 periods of this graph, and there's my second period. So maybe just a little summary of what we have done. So the graphs of our sine and our cosine graph, we have the following characteristics. So if we want the amplitude, I want to think the absolute value of A. If we want the period, I want to think 2 pi over the absolute value of B. If I want to think frequency, I want to think reciprocal of period, so that's absolute value of B over 2 pi. And then if I'm thinking, well, what do the other values tell us? Well, that H value, that's a phase shift. If I'm thinking vocabulary for trig functions, it's a phase shift of H, we would say, before like a horizontal shift left or right, same idea. The K value, we can say it's a vertical translation of K, so meaning moving it up or down. We will do more with this in class. That's just the basics to get you amplitude, period, and frequency. We'll do a lot more of the trig graphing by hand, and you're going to get the hang of it. Okay, hope this helped. Don't forget to like and subscribe. Have a great day.